Picture this. A Ukrainian commander on the Kharkiv front opens a laptop, draws a box on a satellite map, and hits execute. Dozens of autonomous drones lift off from concealed positions. They are not being piloted. There is no joystick, no first-person video feed. Each drone carries a small explosive charge, an onboard camera, and an artificial intelligence chip that can identify a tank, a trench, or an artillery position without human guidance. They spread across the sky in a coordinated pattern, communicating with each other over a mesh network, distributing targets among themselves. If one is shot down, the others reorganize instantly. This is not science fiction. This is the front line in eastern Ukraine. A single Ukrainian first-person view attack drone costs roughly $400. The interceptor systems used to stop drone threats can cost anywhere from $100,000 to $4 million per shot. Ukraine now manufactures more than 4 million drones per year. That is more than all NATO countries combined. By comparison, the United States produces around 100,000 military drones annually. Ukraine is building 40 times more, and it plans to double that number again by the end of this year. But here is what most people miss. The drone itself is not the revolution. A $400 quadcopter is just hardware, cheap, disposable, and replaceable. The weapon that is actually rewriting the rules of modern warfare is invisible. It's software, and the nation that masters it first will not just win the next war. It will make the current model of military power obsolete. To understand why, you have to open up the swarm. Imagine you are sitting behind an air defense console. Your radar screen lights up with 200 incoming contacts. You have seconds to react. But these are not cruise missiles flying in a straight line. They are small, low, slow, cheap, and they are moving in a pattern that keeps shifting. Every time you lock onto one, 3 more change course. Your interceptor missiles cost millions of dollars each. The incoming drones cost less than a used laptop. And there are 200 of them. This is the nightmare scenario that every modern military is now racing to solve. And it begins with one question. How do 200 cheap machines coordinate like a single organism? The answer is 3 layers of technology stacked on top of each other. The first layer is mesh networking. Each drone in a swarm communicates continuously with its nearest neighbors, sharing position, speed, battery status, and target data. There is no central server, no mothership. If you destroy one drone, the network routes around it, the same way the internet routes around a broken node. The swarm degrades gracefully instead of failing catastrophically. The second layer is distributed decision-making. Each drone runs its own lightweight algorithm that assigns targets, avoids collisions, and optimizes the attack geometry, all without waiting for instructions from a ground station. This is critical because in modern electronic warfare, the radio link between an operator and a drone can be jammed or severed in seconds. A swarm that depends on a human pilot for every decision is a swarm that dies the moment the signal drops. A swarm that thinks for itself keeps flying. The third layer is the one that changes everything. Onboard artificial intelligence. Tiny chips called neural processing units run computer vision models trained to recognize vehicles, fortifications, and equipment from thermal and visual camera feeds. The drone does not fly toward where the target is. It calculates where the target will be a fraction of a second later and flies there instead. This is predictive targeting at machine speed. In January of this year, the Pentagon demonstrated something that had never been done before in a live-fire exercise. Under a program called Swarm Forge, a single human operator launched a coordinated lethal strike on 3 separate targets using 3 swarming drones. None of them were individually piloted. The drones selected their own approach vectors, communicated with each other in flight, and struck simultaneously. The operator's role was mission commander, not pilot. If any drone lost communication, it was designed to continue the attack autonomously. The Department of War's own chief technology officer posted the footage with 5 words. The future of warfare is now. The mathematics of modern air defense are broken, and the country that proved it was not a superpower. It was Ukraine. During the Red Sea campaign against Houthi forces, the United States Navy fired SM-2 interceptor missiles, each costing roughly $2 million, to shoot down drones that cost a fraction of that. Analysts call this financial attrition. You do not need to destroy your enemy. You just need to make them spend millions stopping something you built for thousands. When a defender fires a $4 million PAC-3 Patriot missile at a Shahed drone estimated to cost $35,000 to $50,000, the attacker wins the exchange, even when the drone is destroyed. Ukraine looked at that equation and flipped it. Instead of using expensive missiles to intercept cheap drones, Ukrainian engineers built purpose-designed interceptor drones that cost between $1,000 and $5,000 each. One model, called the P-1 Sun, is built on a 3D printed frame. It costs about $1,000. It destroys incoming Shahed drones by physically ramming into their propellers at over 150 kilometers per hour. A $1,000 kamikaze quadcopter killing a drone that costs tens of thousands. That is the new math of war. And the production numbers are staggering. Ukraine manufactured roughly 800,000 drones in 2023. 2.2 million in 2024, 4 million in 2025. The target for 2026 is 7 million. That production curve has doubled every single year since the full-scale invasion began. Ukraine's Brave One Defense Innovation Marketplace now lists over 1,300 different drone models and variants. On the ground, 15,000 unmanned ground vehicles were deployed in 2025, up from 2,000 the year before. According to Ukraine's president, drones now account for roughly 80% of all damage inflicted on Russian forces. But if the drone is just cheap hardware, $400 of motors, a camera, and a battery, then why did we say the real weapon is software? Because the next evolution is not about building more drones. It is about what happens when they start thinking for themselves. In March 2026, a small company called Swarmer became the best performing initial public offering of the year. Its shares surged roughly 950% above their $5 offering price in its first days of trading on the Nasdaq. Swarmer does not build drones. It builds the software that makes them think. Swarmer's platform has been used in over 100,000 combat missions in Ukraine since April of 2024, according to the company's filings. Its system allows a single operator to coordinate an entire swarm of drones, turning individual machines into a unified strike force. Each mission generates data. That data feeds back into machine learning models, which improve targeting, navigation, and coordination for the next mission. It is a continuous improvement loop built on real-world combat experience that no laboratory simulation can replicate. And Swarmer is not alone. Germany's Helsing, valued at €12 billion, has delivered thousands of AI-equipped strike drones to Ukraine, the HF-1 and the more advanced HX-2. These systems use onboard artificial intelligence to navigate and identify targets without GPS or a continuous radio link, making them resistant to the electronic warfare jamming that disables conventional drones. A single operator can manage multiple drones simultaneously through Helsing's networked software platform called Ultra. But autonomy creates a new and unexpected vulnerability. An autonomous swarm does not just need drones, it needs compute, processing power, cloud infrastructure, and data pipelines. The Atlantic Council recently published an analysis warning that if Russia severed Ukraine's tactical data links to Western cloud services, the architecture of autonomous warfare could collapse within days. Ukraine operates roughly 58 data centers. Russia has over 250, and Russia is deepening its artificial intelligence cooperation with China, which already supplies an estimated 80% of the critical technologies used in Russian drones. This is no longer just a war of drones. It is a war of chips, data centers, and algorithms. The side with better hardware can build more machines, but the side with better software can make each machine more lethal, more adaptive, and more independent with every single engagement. That is the arms race that matters now. And looming over all of it is a question that no treaty, no policy, and no international body has managed to answer. What happens when the machine makes the kill decision? Ukrainian drones are already engaging targets with AI handling the final guidance phase, the last half mile to impact. Humans remain in the loop for the decision to strike. But as the swarms grow larger and the engagement windows shrink to fractions of a second, the practical space for human judgment is narrowing. The campaign to ban autonomous weapons urged international action by 2026. That deadline has arrived. No agreement is in sight. We are building the most expensive military systems in human history. Aircraft carriers that cost $13 billion. Fighter jets that cost over $100 million each. Missile defense networks that span continents. And they are being challenged by machines that cost less than a smartphone, built in garages by engineers working off kitchen tables. The hardware is cheap, disposable, and multiplying. The intelligence, the AI that coordinates the swarm, is the decisive capability. And the geography of conflict has shifted. The new contested territory is not a border or a strait. It is the electromagnetic spectrum, the data center, the compute node. In Episode 1, we covered how directed energy laser weapons are rewriting the cost equation of defense, intercepting targets for as little as $2 per shot. Those lasers may be one of the few technologies that can match the economics of the drone swarm. A $400 drone versus a $2 laser shot. That is the equation that will define the next era of warfare. And whoever solves it first holds the advantage. The next major conflict may not be decided by the general with the best plan. It may be decided by the algorithm with the best data. This is Null Inertia, the point where technology meets territory. Thanks for watching.